folks in grade 10 academic and applied science. This is the first and what I hope will be some number of installments of tutorials on some of the basic skills involving light rays, mirrors, lenses, refraction, and so on, and helping you to get through some of the skills should you need it. This might serve to be a good review for you for a test, or it might serve for clarification purposes, or it may simply help you if you're having difficulties, something that you can look at. So I do hope this will be helpful for you, and I hope you get a lot out of it. So let's begin. The goal of this particular tutorial, number one, is to allow you to, I'll just put this down here for now, to allow you to be able to determine the location and characteristics of an image by using the 4 ray rules. And so let's begin. I've got already prepared here a concave mirror. It's concave because I'm going to just put the backing on here. So this backing indicates that it's the back side of the mirror. Do the same thing for these guys. So it's important to put these little marks on here. It just gives you an idea as to what's, especially with these kind of mirrors, because you can't tell on the surface whether or not it's being used as a concave or a convex shaped mirror. So I'll just put those in. So there, now we've defined the back side of the mirror. So what we need to do is we need to put on our key reference line that we've already defined and you're already aware of, and it's the principal axis. And on the principal axis, we're also going to put some letters that are also reference points, and very important points when locating images in these type of concave or caved-in shaped mirrors. These mirrors are also referred to as converging mirrors, because converging mirrors are mirrors that converge light to a focal point, as I demonstrated to you using the ping pong balls. So there is our first principal axis with key points on that principal axis. And I'll just put this out of the way for now. So I'm going to define these for you. So this line is the principal axis, and it is at right angles or normal to the center of the mirror. The center of the mirror is called the vertex of the mirror. This point here, the focal point, is where 3 parallel rays of light would meet if you shone them at the mirror. So there's a ray of light. This could be coming from a laser or from your ray box. So there's the 3 parallel rays of light, and all 3 would simply meet at this common point, and that common point is called the focal point. So I'm just going to get these out of the way now. And the other point that's of real significance here is what's called the center. Now the center is very easy to locate. The center is exactly the same distance that the vertex is from the focal point, and the center is that same distance to the focal point. So FC is the same as FV in all cases. All right? Oh yeah. So there's the 4 ray rules for locating an image in a concave mirror. So rule number 1 is, they're all really reasonably straightforward. Rule number 1 simply says this. Let's just choose red in this case. Any ray of light that is parallel to the principal axis, you can see they're parallel, will always reflect so that it goes through the focal point. That is ray rule number 1. And I think that makes sense because when we had our 3 parallel rays of light, they all went through the focal point. So again, with the ping pong balls, if I was to drop a ping pong ball, it would bounce inwards to the center as opposed to bouncing out. All right? The next ray rule, again, what we need is we need to have our principal axis. And there's our measuring device again. So that's the principal axis. This point is the vertex. It's the center of this curvature. This is the focal point, and this is the center. And again, the distance FC is the same as the distance FB always. So you can say that C is really 2F. That is twice this distance. Oh, by the way, I do want to make mention here that this distance right here from the mirror to the focal point is given by small letter f, and that stands for focal distance or focal length. So this is the focal length of the lens, and this is the focal point, or mirror, and this is the focal point. For this mirror, and by the way, if I say lens instead of mirror, the same ray rules apply for lenses. When we do lenses, you'll find that this is just old hat because it's basically the same. Alright, ray rule number 2 says, and it's the reverse of this one, as you'll see in a minute, any ray of light that goes through the focal point will reflect in such a way that it is parallel to the principal axis. Well, if I was to put my ray box, instead of putting my ray box here and shining a ray of light, if I was to put my ray box here, the ray would simply follow this path, hit the mirror at this location, and it would reflect back. That's called the principle of the reversibility of light. Light, the path of light, is reversible. So you can see that this and this are similar. That's ray rule number 2. Ray rule number 3, let's get a line here. Let's just define things again. We need a principal axis. We need a vertex. We need a focal point. And we need a center point. And once again, using our measuring stick, this distance and this distance are always the same. Now I can put in my next rule. The third rule is very simple. It simply says any ray of light that passes through the center point and hits the mirror will reflect straight back upon itself. So you won't actually see a separate reflected ray. You'll see one ray that simply bounces back on itself. Very much the same as plane mirrors. When you had a ray of light hitting the plane mirror normal at right angles to the mirror, it just bounced straight back. And that's what it does if you shine it through the center. The fourth rule is our principal axis. Just label it PA. It's got the vertex point. It's got the focal point. And it has the center point. The fourth rule is a little more complicated, and by the way, you only need to use 2 of the 3 rules. All you're going to need to locate an image is an intersection point. And to get an intersection point, you need a minimum of 2 lines crossing. More on that on another tutorial about locating the image in a concave mirror. For this tutorial, it's simply showing you how to draw the rays of light for the rules. So my last one, let me put an arrow on that blue. My last rule is, like I say, a little bit more complicated. Any ray of light that hits the vertex will reflect back in such a way that the angle of incidence from the PA, which is like the normal, is the same as the reflected angle or angle of reflection from the principal axis. Now I might be a little bit off here, and I'll make that a little bit bigger. In other words, it follows the law of reflection. They all do, really, but this one most obviously. In other words, if I was to put a plane mirror right here, right there, then the ray of light would come in, it would hit this plane mirror and bounce out. So right at the vertex, it's just like you have a plane mirror. So quick review. Ray rule number 1. Let's just make sure we follow these. So that's number 4, and this was number 3. So in ray rule number 1, any ray of light that you shine from a ray box using a single slit from your ray box that goes parallel to the principal axis must bend and go through the focal point. Similarly, in reverse, any ray of light that you shine that goes through the focal point must reflect parallel to the principal axis. These are just mirror images of each other. They're reverse of each other. The third rule is probably the simplest. Any ray of light that goes through the center will bounce back and go straight back on itself. So you'll only see one light on. And last but not least, any ray of light that strikes the vertex will reflect in such a way that the angle that it comes in at will exactly equal the angle that it leaves at. This one's a little bit trickier to do. You don't have to do this one if you don't want. You just need to choose 2 of the remaining 3. There you go. The 4 ray rules for locating an image in a concave mirror. Subsequent tutorials will talk about the 4 variables for locating the image in a convex mirror, and ultimately how to locate an image in these mirrors and what are the characteristics of each. I do hope this has been helpful for you. Enjoy. Thank you very much.